What we wanted to do was create an arithmetic and a geometric sequence from the following kind of starts, right? So how about this first thing? 0, 1, then arithmetic sequence, what's the next term?
2, 3, 4, and so on. 5.
Okay, and then we're counting, right?
Yeah.
Okay, that was chill, because we were what? Adding 1. How about the geometric sequence for the same?
Divided by 0.
It doesn't.
Yeah, all right.
Why?
Yeah,
You
okay.
could, you could just use. I just did the 1 to the 0.
Okay, so there is not, in fact, a geometric sequence that starts with 0 and goes to 1, right?
Okay.
It's 0 times anything is.
But if you have anything over itself, you have 1.
This one's a trap. And one of the reasons that you might notice this is a trap, right, is that you might try to figure out what R is, right?
Yeah.
How do you figure out what R is?
Multiply by something?
Well,
Divide it.
R should go from here to here, right?
Yeah.
So I'm wondering,
0 times r equals 1.
yeah, exactly. You guys see that? So we're going to write 0 times R equals 1. And then to find R, we could divide both sides. Oh, I'm not even...
You just broke
Right? I should hesitate to even write that down because it doesn't make any sense.
Got it.
You guys see that?
Yeah.
But 0
Okay.
over 0.
Does it equal 1 or does it equal
And
0?
you have the same denominator.
0 over 0 is still not defined. And it's still not defined because it causes all sorts of problems.
But we can make it work.
No, we can't.
We can
Because
talk
it
to
can
some
be
people.
anything.
Get Stephen Hawking in here. We can get this going.
I don't even think he knows.
Neil deGrasse
No.
Tyson.
Look, I haven't lied to you about 0 over 0. It's not defined anywhere.
Okay.
You won't find a number system where 0 over 0 is defined in a sensical way. At least not that goes with the real numbers. So if you want it to work with the numbers we know and love, you have to leave 0 over 0 out of it.
Okay.
Okay.
So lonely.
How about 2 and 3? So
2,
3,
4,
4, 5
It's like this.
for the arithmetic one, right?
Correct.
And 1.
Okay, so then we're counting again.
You can't do it.
And geometrically,
Yes, you can. You do multiply it by 1.5.
yeah.
That's what I said.
So we do 2, 3,
4.5?
3 times 3 halves, right?
Yes.
You guys see that?
Yes.
Should be 9 halves, which
Okay.
is Angela's 4.5.
Yeah.
And then the next one would be
I don't know.
that stuff times 3 halves, right? So we've got 3 times 3 times 3 over 2 times 2. Give me 27 quarters. You guys see that?
Yep.
And then kind of continuing on in this pattern, right? Yeah, and so the pattern is you multiply by a 3 on the top and a 2 on the bottom,
Okay.
right? Because you're multiplying by 3 halves
Right.
each stitch. You okay with that?
Yeah.
Okay, how about this guy?
Did he?
A third, a 9. Oh wait, a third negative a 9? Which one are you doing?
I subtracted the bottom by 12,
Oh,
or you can't do that?
You're supposed to find a common bottom.
so to be an arithmetic sequence, what I need to do is I need to ask, what did I add to this guy to get to that?
Take away 2.
It's going to be negative a third and then negative a ninth,
So you got
right?
negative.
So really here I'm wondering, whatever this
Negative
is going to be
a third.
subtract a third and also a ninth. You guys see that? So I need to figure out what a third plus a ninth is. You guys know what
Negative
4?
Then you can find a common bottom and it's 3 over 9 and then it's
Yep. I need a common bottom, right? It's 9.
It's 2 9.
So that looks like 4 9. So this next guy is negative 5 9.
So 1. 1.
And then the next one is -1. And then the next one is -13/9. And kind of continuing.
So true.
Yeah.
You guys okay with this? That one was super weird, right?
Yeah.
How about the geometric sequence for this one?
Wait,
Multiply it by a negative third.
Multiply by negative.
negative a third.
Yeah, the multiplication function is -1/3, so the next one is
Negative.
Negative positive 127.
perfect. Positive 1/27th, and the next one after that will be
Negative
-1/81st, and kind of so forth. Okay? How about Story's sequence of 6 minus 6? What's that arithmetic?
Subtract 12.
Yeah, we subtract 12, so we go 6, -6,
Negative 18.
-18,
Negative 30.
-30, and so forth. How about geometrically?
Multiply by negative 1.
Multiply by -1, so we go 6, -6,
6.
6.
6, -6, 6, -6. So many sixes. Thanks, Story. You made the devil's sequence up here.
That's
That's a demonic sequence there.
You should have chosen that.
Cool. Maybe we should have chose the 7.
We're
Yeah.
gonna title that sequence
Um,
Devil's Lettuce.
This thing, this kind of alternating behavior is actually also important later. So maybe the kind of best example of this is the 1 minus 1, 1 minus 1 geometric sequence. How about this guy? 4, 7. If we're doing arithmetic, what's the next one?
10,
And
13.
Okay, those were pretty easy, right?
Yeah.
Okay, how about geometrically?
Divide 7 by 4.
Divide 7 by 4.
So 4.
Okay, so I got 4, 7, and then
12, 19.
It's multiplied by 1.75.
so I need to multiply by,
1 1/4.
wow,
One and
you guys are really decimaling me today.
Sorry.
Fraction me instead. What's the fraction?
1 and 3/4.
1 3/4?
So 5/4.
So some incomprehensible 7/4, right? So this multiplication was right. Multiply by, not 4, but
1.75.
7/4.
Yeah.
So my next multiplication should be multiply by 7/4, right?
40, yeah,
Yes.
49,
49
16.
16.
So I get 49 fourths. And then the next one is
300.
whatever 7/4 times that is. So 7 times 49 over 16. You guys see that? These are hard to keep track of writing this way. They might be better to keep track of as we had 7, and then the next one was 7 squared over 4. And then the next one is
7 cubed.
7 cubed over 4 squared.
Okay.
Right?
Yeah.
Why is this easier to keep track of with exponents?
Because you don't have to write the huge numbers.
Yeah, because I don't have to write the huge numbers, and because that's how they work, right? They're AR squared, AR cubed. So if you just keep the powers in there, it makes it a little bit easier. This next one would be
7 to the 4th
over
4
over
to 30.
4
4
cubed.
cubed,
Yeah.
and then kind of so forth, right?
Oh, can I just write that now on? That's a lot more easier for me to figure it out.
Yeah, and I really wouldn't expect you guys to multiply these numbers together. I would really expect you to keep it in kind of exponential notation.
I know this sounds like a dumb question, but how did you find out the fractions to get that number? Those numbers, like for the two fractions?
Yeah, so I thought to myself, to get from here to here, right? In an arithmetic sequence, I'm looking for something I add, right? So I take this thing and I subtract that one. That tells me what I added. So I'd get 3. That's actually how I got this kind of really messy 4/9 number over here. For these guys, for the geometric one, I'm asking what did I multiply by?
And you can just divide 7 into 4.
So if I want to know what did I multiply 4 by to get 7, I'm looking to solve the equation 4 times r equals 7.
Okay, that makes sense.
So I just divide by 4. And really, this is another thing we could kind of do. We could think to ourselves, you know, if I'm wondering, is this a geometric sequence? I could just take each successive pair, divide them, and see if it's all the same. You guys see that? And if it's not the same, it's not a geometric sequence. How about this last guy with 1 and -2? What's the arithmetic progression here? Add -3. So I go 1, -2,
-5,
-5, -8,
so on.
8, and kind of so on. And the geometric progression is
Multiply by negative.
multiply by -2. So I go 1, -2,
4,
+4,
-8,
-8,
etc.
+16, and kind of so on.
Yep.
You might spend a second thinking to yourself, is there a way that I could get some kind of a thing, maybe a geometric sequence where the signs didn't alternate? You guys see that? So on our geometric sequences, right? This guy, this guy, this guy, this guy. Not, it's a trap. This guy. The signs were either what? All the same or alternating? Could you spend a second? You might think to yourself, is there a way I could get the signs to take like every third one or every fourth one, or?
Because if you're multiplying, it's either a positive and negative or a negative and a negative, and you're never going to get them in a row.
You guys see that?
Yeah.
So this is actually a behavior of geometric functions, right? They're either all the same sign or they alternate. There's no other option. Cool? All right. Can anybody give me an example of one of these? I asked for something that's predictable multiplication but isn't a geometric sequence.
I did like
You
adding
rephrase that.
1 and then add. I
Would that
added
just be
1, then I add
Multiply by
2.
1.
Okay, so give me that sequence. What do you got?
I got 2, 2, 4, 4. Because I'm adding 1, and then I'm adding 2.
Like this?
Yeah. So I added the 1.
So then it'd be, is this the sequence you had in mind?
Yeah.
So
So it's
do
1.
you guys see what she's kind of created here?
Multiply by 1.
1 by
So
1
you
and
multiply by 1
2.
and then add 2, okay.
So we multiply by 1 and then
Multiply by 2. Oh, multiply by 1.
Yeah.
What would that hard?
3 is 1 and 2.
Yeah, or 1 common.
is this a geometric sequence?
No.
No, it's not. It's an example of something horrible, right? You can see that sometimes the sequence isn't anything we have a name for. This one specifically is,
Yeah.
there's a really predictable pattern, right?
Yeah.
And I can certainly get the 25th term in this sequence pretty easily. But this one isn't one of our categories, right? We have our 3 categories. There's arithmetic, which is adding consistently. There's geometric, which is multiplying consistently. And there's the harmonic sequence, which is
Fractions and
Which is like 1 and a bunch of
1 in fractions.
which is 1 in a bunch of very predictable fractions.
1/3. 1/2. 1/3. 1/4.
And not anything else, right? This is the capital T harmonic sequence.
Wait, what's that one called again?
The with a capital T harmonic sequence, okay?
You have to write out with a
It's
capital
in
T.
that one. Cool? So like, for instance, remember if we cover the 1 up, it's not the harmonic sequence anymore. This is a very specific thing. Cool?
Cool.
Questions about these? Okay.